So we're going to start having a look at molar concentration. So of course, first of all, we're going to have to do a little bit of quick revision of the mole. For this, we're not typically going to be using the number of molars equal to the number of particles divided by Avogadro's number. We're typically going to be using our N is equal to M on MR formula. Okay, remembering that the symbol N stands for moles and that the unit is also mole, and that we have that definition that it is the number of particles in 12 grams of carbon-12. The Avogadro's constant, 6.02 times 10 to the 23, is provided in your data booklet. Okay, so this will always be in your data booklet if you forget what it is, though you're unlikely to. Okay, so in the data booklet or data sheet. Okay, and so this formula here is the one that we're going to typically be using when working out our number of mole per litre or concentration in molar. Okay, so remembering mass must always be in grams, so if it is in milligrams or kilograms, we need to convert. Okay, number of moles is always N, and then molar mass is adding up each of the molar masses from the periodic table, okay, using our formulas to do so if it's not given in the question. So let's have a look at a few examples and bits and pieces. So as I said, molar concentration is defined as the number of moles of solute particles per litre of solution, and this time we're counting the solute particles in terms of mole. So a 1 molar, or 1 capital M, because this capital N is the unit molar, okay, which is equal to moles per litre. Okay, so we can either write the units as capital M, or we can use mole / litre, or we can use mole litres to the -1. All of these means molar concentration. Okay, so when we have this formula, we can know, remembering that concentration is equal to the amount of solute divided by volume. So this will be number of moles divided by volume, where volume must always be in litres. Okay, must be in litres to use this formula. This means that we end up with a new formula for the mole, which is N is equal to concentration times volume, just rearranging this one here. Okay, so the key thing here is to remember that we must convert our volume into litres, and we can only take the amount of substance as mole in order to give molar concentration. The other thing is that when we talk about molar concentration, if I have 1.5 and put it in square brackets, that means the concentration or molar concentration. Okay, so if I'm talking about the molar concentration of magnesium ions, I would put it in square brackets, and we'll see that notation moving forward a little bit more. Okay, so usually we won't see it as a number. We'll usually see, say, the molar concentration of sodium nitrate will be written in square brackets like that, just a note on notation. So we refer to molarity as the molar concentration. Okay, so when we're talking about this, when we talk about making up solutions of a particular molar concentration, we will take our substance. Okay, so we'll need to know the mass of the substance so that we can calculate the number of mole. Place it into an accurate piece of glassware, like a volumetric flask. Dissolve the solute into solution. And then finally fill up to, there's a calibration line here, up to the calibration line, which will be the final volume. Okay, so this, in this case, is likely to be a 250 ml flask. Okay, so in this case, we might take 0.25 mole of a compound, place it into the flask, dissolve it in the minimum amount of water, and then fill to the line. And that would give us 0.25 mole in a 0.25 litre flask if it was 250 ml. Okay, so we divide that by 1,000 to get 0.25, okay, which is going to be equal to a 1 molar solution. So 1 mole per litre, okay, or 1 molar. solution. So this is how we go about making these solutions, filling up to the line, the final volume, so that the volume of the solute is considered in the solution as well. If we were to take our solute and just dissolve it into 250 milliliters, the final volume would actually be higher than that because we will have had some extra volume taken up by the solute. So this, when we make solutions, we make up solutions, so we always take to the final volume. Okay, let's have a look at some example calculations. So we're asked here to calculate the concentration in moles per litre of a 5 mole of sodium chloride dissolved into 10 litres of water. Okay, so in this case, we're going to have concentration is equal to the number of mole divided by the volume, and we're just going to substitute in from our equation. So in this case, we have a number of mole, which is going to be N, okay, and then we have the volume here, which is correctly in litres. Okay, I don't need to worry about molar mass or anything like that because I have been given the number of moles. So this is a simple substitution. So I'm just going to take my concentration is equal to 5 divided by 10, okay, which is going to give me 0.5 mole per litre, okay, or 0.5 molar. This is exactly the same thing. In number 2, we've been asked to calculate the concentration in moles per litre of 40 grams of sucrose. So we'll notice here I have a mass. Okay, we're given the formula. Sorry, the formatting has fallen out of this slide. And then we're given a volume. Okay, this volume is in milliliters, so I'm going to have to convert that to litres, so 250 times 10 to the negative 3 litres. Always remember to convert straight away. Because I have a mass, I'm going to need to work out my number of mole. So in this case, we're going to have number of mole is equal to mass divided by molar mass. I have 40 grams of sucrose, and I then have a formula. So I have C12, so I'm going to have 12 times 12.01 plus 22 times 1 from the hydrogen plus 11 times 16, which is my oxygen. So when we do all of that, so we're going to have 12 times 12.01 plus 22 plus 11 times 16 is going to be 342 grams per mole. So 40 divided by 342 grams per mole is going to equal 0.11696 mole. Okay, so this is my number of mole. I still need to work out my concentration. So concentration, in this case, I'm going to work out my concentration is going to be equal to my number of mole divided by my volume in litres. So my number of mole is here, 0.11696, divided by 0.25, which is 250 divided by 1,000. And when we do that, we get 0.468 molar concentration. Okay, so this is 0.468 molar concentration, taking it to 3 significant figures. Okay, so they're the 2 simple types of equation that we can have: a simple substitution where the number of mole is given, or the combination of using our N is equal to M on MR formula, and then concentration is equal to the number of mole on volume. Concentration. So I'm going to go through a few more calculations. If you feel like you've got this, you can stop watching the video and try your textbook questions, or you can watch these different examples for the different types of calculations that we're going to see. So now we're asked to calculate the amount in mole. So we're looking for N of sodium hydroxide. that will be required to take a 10 milliliter solution, so this is 10 times 10 to the neg 3, of 0.825 molar. So this one is a concentration. So if I look at this, I know that N is equal to C times V, because concentration is equal to N on V. So I can use this one here because I'm looking for the number of mole. I do have a concentration. Okay, here, this is my concentration. I do have a volume, so I can just substitute in, and I will get N is equal to my concentration, 0.825, multiplied by my volume, which is going to be 0.01, because I need to convert it into litres. So if I plug this into my calculator, I'm going to get 0.825 multiplied by 0.01, and I'm going to get 0.00825 mole. Okay, so that will give me a 10 milliliter solution that has a concentration of 0.825 moles per litre. Okay, so I'd need to measure out that much sodium hydroxide. Of course, we can take that question further and work out the mass of sodium hydroxide by using that number of mole and using N is equal to M on MR and rearranging to find M. So remember that these can be combined. So, and this is what we're going to see in this one here. So calculate the amount in grams. So I want a mass of sulfuric acid, H2SO4, that will be required to make a 300 ml, 0.3 litres solution of this concentration. Okay, so first things first, I can see that I have a concentration, I have a volume, and so therefore I can work out mole. And then once I have mole, I have molar mass, and I can work out my mass. So first things first, let's start with our concentration. So if we have concentration volume, we want to find N, we're going to use this one here. N is equal to C times V. So concentration is 0.513 multiplied by 0.3 litres is going to be 0.1539 mole. So that's my number of mole. So I have sulfuric acid. I know that N is equal to M on MR. I want to find mass. So I can start substituting in. My number of mole is 0.1539, and then I need to multiply by the molar mass, which is going to be 2 times 1 plus 32.1 for the sulfur plus 4 times 16, which is going to be 64. So if I put all this in, I'm going to get 2 plus 32.1 plus 64 is going to be 98.1. And then if I have a look at that, multiply by my number of mole, I get 15.09 grams of sulfuric acid is how much that we would need to have. Okay, so that would be the number of mole of sulfuric acid that we would require. And in the correct number of significant figures, it's going to be 15.1 grams. So that's combining our two equations for the mole to work out the concentration or to work out the mass to make a specific concentration. So one of the key things here is unit conversions. Okay, so if I have something in grams per litre, okay, if my concentration is given in grams per litre, what I need to do to convert to moles per litre is, of course, take the mass of the substance and divide it by the molar mass. Because I already have 1 litre, this is going to give me moles per litre concentration. If I am given a concentration in moles per litre and I want to get it in grams per litre, I am going to multiply my number of mole by the molar mass. So we can easily convert between these 2 units of concentration. So a couple of things to remember. Molar concentration refers to the amount of solute that's been dissolved in a given volume of water. By definition, 1 molar solution is 1 mole dissolved into 1 litre of solution. Okay, so now we need to think about how this relates to aqueous solutions and the number of particles that are in there. So if we think about HCl, we know that HCl, when dissolved in water, if I have 1 mole per litre, we would have 1 mole of hydrochloric acid molecules per litre of water. But we also know that HCl ionizes in solution, so HCl plus water is going to give us H3O plus or H plus and Cl minus ions. Okay, so it's not actually going to be in molecules. So we would have 1 mole, remembering that this is the equivalent of H plus, 1 mole of H plus ions as well as 1 mole of chloride ions. Okay, so we can refer to the concentration in terms of hydrogen ions as being 1 molar. Okay, and in this case, because it's a 1:1, we would also have a 1 mole per litre concentration of chloride ions. Okay, in the case of, say, magnesium chloride, if I had a 1 molar solution of magnesium chloride, the concentration of magnesium ions would be 1 mole per litre of magnesium ions. So I could say concentration of Mg2 plus is equal to 1 mole per litre. But in the case of chloride ions, because there are 2 chlorides per magnesium, I would have 2 mole per litre of chloride ions. So the concentration of chloride ions would be equal to 2 mole per litre, okay, because it depends on the perspective that we're taking and what we're counting. Overall, it would be 1 molar solution of magnesium chloride. Okay, so let's look at this in terms of some examples. So if I have 0.5 mole per litre, so this is my concentration, of copper 2 sulfate, so CuSO4, what would be the concentration of copper 2 plus ions and sulfate anions? Okay, we know that when we have copper sulfate dissociating, we get Cu2 plus and SO4 2 minus. So we can see this is a 1:1. So if I have 0.5 molar of copper sulfate, then I'm going to have 0.5 moles per litre of Cu2 plus, and I will have 0.5 moles per litre of SO4 2 minus ions. Okay, because I will get 1 ion for each one. If we look at 0.25 mole of nickel chloride though, when I have nickel chloride dissolving into solution, I'm going to get nickel 2 plus 2 lots of chloride ions. Okay, so with this 2 lots of chloride ions, what we're going to end up with is from 0.25 moles per litre of nickel chloride, I will get